I just want to put some context to this presentation by telling you what the Lenovo Datacenter Group is, which in a few words is just the result of the acquisition by Lenovo 2 years ago of the IBM System X division, bringing to Lenovo not only the technology, which is important, but also the people, and most important, the know-how and the huge installed base worldwide, also including many large HPC installations that are demonstrated in the top 500 list, with several tens of installations powered by Lenovo technology. Well, as a heritage of this old IBM days, we have the spirit of openness, of innovation and collaboration. For that purpose, we opened last year an innovation center focused on HPC in close collaboration with the main industry leaders such as Intel, Mellanox, NVIDIA, or IBM itself, but most important, with our key customers that we find can play a key role at defining the future needs and the future technology for any kind of HPC environment. That way we are keeping track of the real life of the supercomputing centers. So this close collaboration is with the main supercomputing centers in Europe, one of them very close to this house, the Barcelona Supercomputing Center. Well, our commitment with the development of standards and then our philosophy of openness, we are collaborating in the development of the API standards. We are members of the InfiniBand Trade Association, Open Fabric Alliance, and we are a founding member of the OpenHPC Community. Well, the intention of this OpenHPC is to provide an integrated framework to manage end-to-end any kind of HPC environment. So we are a founding member. We are collaborating with many of the projects, with most of the projects that are part of this framework, and we are also the owners of some of them that I will explain a little bit later on in this presentation. Well, we have as well signed recently a couple of important collaborations in the open source software stack. One of them is with the Barcelona Supercomputing Center, which is developing jointly with us an energy-aware MPI runtime that is intended to decouple the energy-aware scheduling from the scheduler itself, to make it scheduler independent, so to say. And another line of research is the virtualization of HPC environments, which some of our colleagues here have already talked about, with several approaches, with traditional virtualization with KVM, and also with Docker, and some other new concepts that are brought recently by some of our researchers in terms of what we call job capsules, which is something related to LXD or singularity or things like that. I will try to speak a little bit about this later on. Also with the Oxford University, as part of the OpenHPC project, is user-friendly user interface, web interface for both the sysadmins and end users to be able to, at a glance, have a quick look on the system health and also the progression of the job submissions and things like that. I will show you some screenshots a little later. Well, a core part of this OpenHPC project is the continuous development of the xCAT toolkit, which we find a very powerful toolkit in many large HPC installations. It is shown in some of our most important customers and installations, such as LRC or BSC. It's a toolkit that includes a lot of powerful features, such as the extreme scalability and also compatibility and support for many hardware architectures, not only x86 based, but also on power, many compatibilities with different OSs, not only Linux based, but also Unix and Windows. The support for the main virtualization engines in the market right now, and the possibility of deployment in some different manners, such as diskful, diskless, or a hybrid. Well, having said this about xCAT, which we consider a very powerful tool, we also see that this involves a complicated learning curve and a long learning curve for new users. So to get the most out of this toolkit, you must spend quite a long time to get familiar with all the features. So in order to simplify a little bit the life of our sysadmins, we have initiated a side project for an xCAT enhancement that is called Confluent, which intends to provide a new interface for sysadmins with a more meaningful set of commands, and that that also improves performance and the completion of such commands by optimizing all the communication with the remote compute nodes. Also providing some APIs to develop further integrations with web interfaces or the like. Okay, talking about web interfaces, we are on the way of, we have already in fact developed a web interface that intends to be user-friendly. But I realized that we haven't started. We should have started from the name itself, which is not very friendly. It's the Open System Management Web Console OSMWC. It's kind of complicated. So we have opened already an internal survey to rename this software, and of course suggestions will be more than welcome. But the goal of this is to provide a user-friendly interface in order to provide both sysadmins and end users with a first glance of and check the completion of their tasks at a simple glance. And not spend much time at issuing strange commands and things like that. We have started the implementation of such tool in the China market. This is because China is an emerging market, and there are a lot of new HPC users in the recent years. So. This was a demand from those users who were new to those environments, and to be able to use that powerful tools without too much difficulty. I think that is okay. Better? Well, I will continue. So this was a demand from the China market because there were a lot of users there wanting to get the most out of their systems, but the learning curve was too long. So we decided to implement some easier way to interact with our system at the first step. And after implementing it into China, we had to face the first problem, is that it was in Chinese. So the first problem we are getting help from the Oxford University with is to translate into English. Who better than Oxford? And also adding new functionalities and improving the performance. So this web console is intended to run on top of the whole software stack which is part of the OpenHPC project. So currently it runs on top of course, xCAT or Confluent as the administration engine. Also integrated with the main MPI implementations, most commonly MPI implementations, as well as Ganglia as the monitoring tool, Torquimaui as the job scheduler, several OSs, parallel file systems, interconnect drivers, and so on on our hardware, because it's what we have in our labs, but of course it's meant to be as open as possible. And the current work items are focused on integration with Slurm as the mainstream open source job scheduler, and also with alternative monitoring tools such as xCAT and the new Intel OmniPath interconnect, which will be very commonly used in the next years, but we are also providing such integration right now. Well, this is the look that this web console will have for the end user. Very simple. Just intended to have a dashboard where the user can see the progression or completion of its jobs, and with a simple button to submit the job just by specifying the job name and the submission script, and that's it. And just with an additional button to upload their local submission script if should he or she wanted to change it, and having this dashboard to see the progression. That's it. And this is the look for the sysadmin. The sysadmin that could have a nice dashboard to at a glance check the system health in a few seconds, and with some buttons to link to the different administration tools, such as the monitoring tool, Ganglia, or xCAT, or whatever. And well, taking aside the administration and management software, this is the concepts on which Lenovo is working currently as part of the research lines that we are sharing with BSc. Well, I cannot tell too much about this because the real specialist is my colleague Dr. Kim. But well, I can just say that it's a concept very similar to Singularity or LXD that our colleagues have explained previously in this conference, intended to provide an environment for a specific job submission, a specific environment without the overhead of having to virtualize any network interface or IPs or any other software. Just by having native access to the network, hardware resources, parallel file system, and so on. So in order also to provide enough flexibility to get the most out of your HPC cluster without having too much penalty and latencies and other virtualizations overhead. So it would consist of a base capsule consisting of the operating system environment, I insist, without virtualizing all those hardware parts, and some expansion capsules that could be loaded on demand, containing the necessary job-specific libraries or any other binaries needed to complete the job. So this is more or less the concept. Of course, I would have liked Dr. Kim to be here to further and explain these concepts and be able to discuss with you. Unfortunately, he's not here, but more or less this is what he wanted to tell you. So, I think that I have been quite quick. as requested by the organization. Of course, I'm open to any question you may have now or later on during lunch or at any time. Thank you very much.